diversity of perspective, diversity of background almost always leads to more impactful solutions. And this is why I always try to emphasize that bridging the gap between data action and impact really requires a range of expertise and therefore a strong collaboration amongst people with different backgrounds and different skills and perspectives.
Hi, I'm Stephanie Tumampos, and you're listening to Down to Earth, the show where we talk to incredible geoscientists about their science and its impacts on our planet. This season, we're exploring the many ways we can harness the power of artificial intelligence to learn more about our world. I'm also on a personal quest to discover if AI will be more of a help or more of a hindrance to our work as geoscientists. One thing that always stands out to me whenever we're talking about remote sensing in any capacity is collaboration. The reality in our field is that this work doesn't happen in a vacuum. We need to connect with interdisciplinary researchers, end users, and decision makers to effectively translate our research into impactful results. This is especially true when it comes to GeoAI. So today, we're speaking to a researcher whose middle name could easily be collaboration. From the beginning of her career in machine learning and geoscience, she has been working with different stakeholders to leverage non-traditional datasets with GeoAI. Her goal? To generate actionable insights and evidence-backed decisions in service of the most vulnerable populations globally. Together, we'll delve into inspiring real-world examples of how she has applied GeoAI in her humanitarian and resiliency projects. We'll also examine the power of interdisciplinary partnerships and the ways we can work in collaboration to harness the full potential of GeoAI for social good. Let's dive in. This episode of Down to Earth is brought to you by the Geoscience and Remote Sensing Society's technical committees. As part of the world's leading professional association for the advancement of technology, the GRSS technical committees are innovation hubs, bringing together experts from around the world to forward cutting-edge geoscience research, development, and applications. To learn more and be part of the premier community driving the future of geoscience and remote sensing, visit grss-ieee.org and join a technical committee today.
Whenever I start a machine learning project, I always ask who will be using the model, how will these models be used, what kind of decisions will be made based on the model outcomes, and how will these decisions impact people on the ground.
This is Isabelle Tingzon, data science consultant at UNICEF under the GIGA initiative. Since beginning her career, Isabelle has been working at the intersection of GeoAI and social good, where she has applied AI and Earth observation for socioeconomic development, environmental sustainability, and humanitarian response, primarily in the Global South.
Without clear mechanisms for action, without these clear pathways to impact, even if your models achieve really high performance scores, like 90% F1, it could end up not being useful. So yeah, I would say at the initial stages of research, it's really important to engage with stakeholders, domain experts, and people who can act on your work, essentially.
Pretty much every project Isabelle has worked on has involved collaborations with multiple different stakeholders. From community members who benefit from her research to partnerships with nonprofit organizations, governments, and more, she has had to navigate relationships at every level. This isn't easy work, but it's important for ensuring the research generated through GeoAI is useful and used. Let's take a look at some of Isabelle's many projects and learn more about how to embrace collaboration in GeoAI. Isabelle, thanks so much for joining us today. We're really excited to speak with you. And I want to begin with a brief summary of your research journey, because it's really been steeped in collaboration, which is the topic of today's episode. So tell us, how did you get involved in GeoAI for social good? And what makes you passionate about it?
Hi, Steph. It's great to be here, and thank you so much for the invitation to this podcast. I guess my research journey began with a collaboration with UNICEF Innovation. So this was back when I was a machine learning researcher at Thinking Machines Data Science. So one of my very first projects was generating high-resolution poverty maps under the guidance of Dr. Do-Young Kim, who is the lead data scientist at UNICEF. Here, we develop deep learning models to estimate socioeconomic indicators from satellite images. Essentially, the work that we did led to a partnership with UNDP's partner NGOs in the Zero Extreme Poverty movement to generate actionable insights for supporting poverty alleviation programs. And this first foray into machine learning for social good really sparked a sense of purpose in me, prompting me to ask, like, what other problems can I solve with this technology? And from there, I was involved in a lot of really interesting problems, from identifying informal migrant settlements in the Venezuelan mass migration context, to working on bolstering climate resilience in the Caribbean. And the work that I'm doing now with UNICEF GIGA, which is identifying schools using deep learning and high resolution satellite images in support of universal school connectivity. All these experiences have really been very fulfilling, very meaningful, and it feels great to be able to use my skills in AI and Earth observation to create a positive impact on society. So it's been a really incredible journey.
You are so inspiring, Isabelle. What makes you think machine learning is a good fit for this type of work?
So the work that I'm doing is applying computer vision to Earth observation data, specifically satellite images, but also data sets like LiDAR data, drone images, and even non-aerial images like street view images. What machine learning or deep learning or more specifically computer vision is really good at is extracting meaningful information from these data sets. By being able to extract meaningful information from these data sets, we can help fill in critical data gaps within humanitarian organizations. One of the problems that we've faced, and I'm sure as a professional in the remote sensing field, you might have also come across this, but essentially there is a lack of high quality data, especially in areas that need it the most. So least developed countries, rural areas or conflict areas where it's hard to collect these data sets. And Earth observation data, because of its global nature, and because of frequent revisit times of satellites, we're able to use AI and machine learning to extract information in a way that is very quick, very scalable. And in that way, we're able to fill in a lot of these critical data gaps that we see in a lot of development contexts.
That makes perfect sense. And let's make this more concrete by diving into your latest work using AI-powered school mapping. This work is part of achieving Sustainable Development Goal 4, which is quality education. So can you tell us more about this project?
Sure. So GIGA, as I mentioned, is a global initiative by UNICEF and ITU to connect every school to the internet by 2030. So this project was a response to the problem of the digital divide. So for context, globally, around 1.3 billion children, which is 2/3 of the world's youth, don't have access to the internet. And this lack of internet connectivity doesn't only limit children's opportunities for online education, but it also prevents them from developing digital skills that they need to compete in our modern economy. Now, in order to reach this target of connecting every school to the internet by 2030, governments and connectivity providers, they need complete and accurate school location data in order for them to reliably estimate the costs of connecting schools and to strategize the allocation of their resources. But a lot of the times, the records that the government has, they lack geographical coordinates, especially in developing countries. So, for example, in Senegal, our government partners estimate that around 20% of school geolocations are missing from their data sets. Another example was, I believe, in Kenya, where they have 33,000 schools, but they only have 7,000 schools with GPS coordinates. So there's a large number of schools that don't have geographic coordinates. And so what we try to do under GIGA, under the applied science team of UNICEF's GIGA, is we try to generate maps of school location predictions using deep learning. and high-resolution satellite images. So we've been experimenting with computer vision models like CNNs, or convolutional neural networks, and vision transformers to classify satellite images based on whether or not they contain schools. And we also use explainable AI methods, if you're familiar with class activation maps, to identify the more precise geolocations of the schools.
That sounds like a very useful project. What's been the response from the government stakeholders so far? And beyond their role as end users, how have you made sure they're actively participating in the project throughout the process?
To encourage AI adoption by government partners, we developed an interactive web mapping tool to streamline human-in-the-loop model validation efforts. So basically, we created an interactive web map to allow government end users to visualize the model predictions, compare them with official school data sets, and validate the predictions by either cross-referencing them against public records like Google Maps or using the predicted lat-long points for field validation.
That's really cool. And obviously, collaboration played a huge role in this project. So tell us about that. And could you tell us why you think collaboration is so important for these projects to be successful?
Right. So for the AI school mapping project, we collaborated very closely with government partners, understanding their needs. For example, when developing the model validation tool, we wanted to know what kind of data they wanted to see on the map. They wanted, for example, to see their own school records compared against the model predictions. And they also wanted to have records of unmapped schools within the platform so that they can match it with the AI predictions. So collaboration is really useful in identifying critical data gaps and determining how technologies like AI and Earth observation can help fill in these gaps.
Mm-hmm. And good communication must play a major role in successful collaboration, right?
Yeah, in collaboration, it's also important to communicate the requirements, capabilities, and the limitations of AI and machine learning models. Basically communicating what type of data is actually needed to be able to train these machine learning models. So, for example, for the school mapping work, we need some sample data points in order to train a model to determine what schools look like in a particular region, because schools can look very different, say, in countries in Africa versus countries in South America.
Mm-hmm. I really love how you emphasize the importance of knowing what the end user needs and how they will use the results of your work. Because in academia, I feel like there's a huge hurdle in terms of translating what we do to the greater public. But you've been doing this in so many areas of your career. So I'm really interested in learning more here. So in 2023, you were first author on a paper that looked at two case studies. These case studies compare different stakeholder engagement levels when applying AI for Earth observation in the global south. So tell us what you discovered.
All right. So in the first case study, I demonstrate an approach where solutions were developed from a purely technical perspective without much stakeholder engagement. And the second example, we collaborated more closely with the social sector. And in my opinion, it was the second case study where we took into account the local context and perspectives that ultimately led to more impactful outcomes. One of the very first data science projects I worked on was generating high-resolution poverty maps in the Philippines, basically taking the methods developed by the Stanford Sustainability and AI Lab and adopting that to the Philippine context. So very briefly, this work involved using daytime satellite images, nighttime lights, and demographic survey data to estimate socioeconomic indicators like the wealth index on a more granular scale. So, while we did achieve pretty good results on paper, our next steps were, of course, to bring these solutions to government agencies and policymakers. But we ended up encountering several barriers to adoption. So one of them was the lack of actionability of our target variable. In this case, we were measuring what was called the wealth index, which is computed as the first principal component of a number of asset-based variables. The problem with this is that the value itself is quite abstract and hard to interpret, even amongst technical users. And when we presented the solution to stakeholders, they wanted more concrete measures of socioeconomic development. For example, percentage of households without access to electricity or number of out-of-school youth in an area, right? So these are like more actionable measures which you can really generate policies or interventions around. Another challenge with the work that we did was that we weren't able to establish policy levers from these poverty models. So what I mean by this is that if, for example, we find our variable like 4G or 5G access to be a strong indicator, a strong predictor of wealth, does that mean that we should establish 4G or 5G networks? Is that like a good next step based on this insight? So probably not, because it's more likely that the causality runs backwards, right? Like telecommunication companies look for wealthy areas to establish 4G and 5G networks, since these are the communities that can afford them. So key takeaway from this was that without the participation of relevant stakeholders and decision makers at the early stages of research, without clear mechanisms for action, without clear pathways to impact, regardless of how well your model performs, your models could end up not being very useful.
Coming up, we learned what Isabelle discovered during the second case study, where they built stakeholder collaboration into the project from the start. Isabelle also shares the secret sauce to getting collaborative buy-in from stakeholders. So stay tuned.
Want to be at the forefront of geoscience and remote sensing innovation? Then join one of the Geoscience and Remote Sensing Society's technical committees. With 8 committees to choose from, you'll find your niche. From earth science, informatics to data fusion and climate technologies, our committees are driving progress and advancing the state-of-the-art in geoscience remote sensing work. Through our networks, you'll collaborate with global professionals, participate in cutting-edge research, and apply innovations to real-world challenges. Enhance your career, expand your network, and contribute to a better tomorrow. Visit grss-ieee.org and join a technical committee today.
Welcome back. Today we're speaking to Isabelle Tingzon, data science consultant at UNICEF under the GIGA initiative. Throughout the first half of our interview, Isabelle provided a wealth of examples where collaboration with stakeholders really impacted the uptake and use of GeoAI solutions. Right before the break, she was telling us about research where she looked at 2 case studies and compared the different stakeholder engagement levels when applying AI for Earth observation in the Global South. In the first case study, the researchers brought the stakeholders into the project at the end and discovered that the stakeholders couldn't effectively use the data. This is because it didn't provide concrete measures of socioeconomic development, so they couldn't develop policy from the data. What did Isabelle's team do differently in the second case study? Let's find out.
So I'll contrast this project with a second case study where we actually started by understanding the problems from a local perspective. So here we actually traveled to the Colombia-Venezuelan border to understand challenges related to the Venezuelan mass migration crisis. This was in collaboration with IMAP and UNICEF Colombia. So basically, through conversations with local NGOs, we became aware of this urgent need to locate rapidly growing migrant settlements all across Colombia, because thousands of migrants were traveling from Venezuela to Colombia to escape social, political, economic turmoil in their home country. And government agencies, local NGOs, and local government units in Colombia were having a hard time keeping track of where all these migrants were located. And they needed this information to provide emergency humanitarian aid. And so we ended up proposing a machine learning approach using historical Sentinel-2 satellite images to accelerate the discovery of informal migrant settlements. And very similar to the work that we're doing now on AI school mapping, we implemented a human-in-the-loop system where we engaged with local contributors and local communities who would physically travel to the locations that our models detected, conduct field surveys, and take photographs, to assess the living conditions of Venezuelan migrants and actually confirm that there were Venezuelan migrants within those areas. And so through this approach, we were able to discover, I believe, over 300 or 350 migrant settlements that were previously unmapped or essentially invisible to these humanitarian organizations. And so I believe this second approach, where we really try to understand the needs of people on the ground and also engage with local stakeholders and local communities, ultimately resulted in much more impactful outcomes compared to an approach where it's developed from a purely technical perspective and only engages stakeholders at the end of the research process.
I'm not surprised by these findings, but it's funny, because in science, we have this specific process where you have a problem, you test methods for solving the problem, and only then do you communicate the results. So it's like this one model fits all approach, and it doesn't always work when it comes to applying scientific results in real world situations.
Yeah, exactly. Like it's really important to develop solutions that are tailor fit to a local context and that takes into account local perspectives. Like one model fits all might not always be the best solution. And I think this is a real problem with a lot of the models that we're seeing in the Earth observation space. We're developing essentially these global models, right? But oftentimes, if you look at the data sets, there are disparities in data availability. Most of the data come from the global north, right? When you have geographic disparities in data collection, you could end up with models or systems that are optimized for particular regions or calibrated to perform really, really well, but only for particular regions. And these regions are often like the more developed countries, right? And so you end up with models that don't perform very well in least developed countries or rural areas. And these are the countries that actually need these types of data sets more, right? And so I would say there's definitely a need for local solutions that are tailored to local context and take into account local perspectives.
Exactly. I totally agree. So when it comes to local context and solutions, is there a difference in approach when collaborating with local governments versus community members?
Yeah, so with government entities or non-technical stakeholders in general, we tend to have a range of understanding of what is AI and how AI can be helpful. So you have people who are very overly optimistic about AI, who are very keen to use AI models to improve their processes, but might not be very familiar with the requirements, the capabilities, also the limitations in terms of using and developing these AI models. And then you also have stakeholders who might not be very open to more innovative solutions. Like they're very set in their ways. Although nowadays with the advent of ChatGPT and LLMs and AI becoming more mainstream, I think a lot of governments and non-technical stakeholders, meaning international development organizations, are becoming more open to the use of AI. So in general, I do think that in terms of getting AI solutions adopted, it does help to have a point of contact in the government it really helps to have someone who's very forward thinking or very progressive, meaning you have people who are able to see the value of using data for evidence-based decision making. And it also helps to have people who are able to navigate the complex bureaucracies of national governments. Because if you can imagine affecting change within these major institutions can be difficult and really slow because of all the red tape and all the bureaucratic processes. But if you have government officials or decision makers who understand your work, who are willing to champion your solutions, and who see the values in these technologies, then that's when real change happens. And it's the same with communities, right? Like if they can understand your solution, if you're able to communicate the value of your work, then they become more open and more responsive. And this is where I think the value of model interpretability and even simplicity of the models that you use come into play. I remember in the poverty mapping solution that we developed, we started with this really convoluted solution where we used daytime satellite images, used convolutional neural networks to map it to nighttime light and values, and then we extracted feature embeddings from the CNNs, and then we used a secondary model, like a ridge regression model, to ultimately estimate the socioeconomic indicators. And like, honestly, because of the black box nature of these models, it led to less trust in the model, and also the computational resources needed to run these models and the cost of downloading these high-resolution satellite images. All of these were barriers to adoption by local NGOs who had limited resources and also limited expertise in AI models. And so when we switched our approach to using more interpretable models like random forests, which if you show them like an image, like a diagram of a decision tree, that's very easy for non-technical stakeholders to grasp. And using more publicly available, more cost-efficient data sets like low-resolution satellite images that you can get from, say, like Sentinel-2 or Landsat, using social media data. So, for example, from Facebook's marketing API, you can get information like number of users who use 2G, 3G, 4G Wi-Fi for internet access, and other information such as point of interest data from OpenStreetMap, which, as you know, is the volunteer geographic information. Using essentially these publicly available data sets coupled with interpretable and much simpler models, we were able to get stakeholder buy-in. And that's what ultimately led to them like sort of accepting our solutions versus using these more convoluted, more complex models.
So the secret sauce to collaboration is really to show value in the outcome mixed with using more accessible, less complex models that end users can understand, right?
Yeah, exactly. And being able to communicate the requirements, the capabilities, and the limitations of the AI models is really important. For example, in the work that we did at GFDRR with my team is that they were able to establish GIS units within national governments. And this enables them or empowers local governments to generate and maintain large geospatial databases. We're also training local governments to collect drone images. This is, I believe, in partnership with the humanitarian OpenStreetMap team, or HOT, basically training local government staff how to coordinate pilots, how to fly drones, and collect drone images on a more frequent basis. And essentially, our pitch around this was that if they're able to collect this information, they're able to collect high-resolution drone images on a more frequent basis, then they can use the models that we've been developing to extract building footprints and roof type, roof material information, essentially exposure data maps, on a more frequent basis, which can be really useful for planning infrastructure, but also for disaster response, right? So just being able to communicate to them the value of these technologies and getting their buy-in is really, I think, really important.
I love how you mentioned so many examples because these are concrete examples that you're giving us. And I know you've already touched on this, but if you had to quickly summarize the core practices for good collaboration, what practices would be on top of your list?
So my response would be, one is building local capacity amongst non-technical stakeholders, democratizing capacity by making these advanced solutions like AI and Earth observation more accessible to a broad audience with different expertise, right? Building local capacity in terms of data collection, in terms of generating data sets using AI and Earth observation to fill in the critical data gaps, and maintaining these systems is really important for sustainable and long-term adoption of these AI solutions. Maybe emphasizing the need for localized solutions. So I mentioned before, taking into account local context and perspectives, understanding who will be using the model, how will the models be used, and how will the decisions based on these models impact people on the ground. And like in general, when we think about AI and Earth observation, it's it's really just a means and not an end. It's a tool. It's only a fraction of the solution. And so these solutions always need to be informed by local problems and societal context. And so it should be seen as a component of the solution, not as the solution in and of itself. That's what makes collaboration really important, because the solution should be comprised of many different actors, right? And AI actually plays like an actually small role, not to trivialize its role here, but it's essentially just a tool that can be used to help make processes faster, more scalable, and more efficient, right? So, I would definitely emphasize the importance of collaboration when developing AI and Earth observation solutions. There should always be some form of human intervention, whether it's in the intermediate or the final decision-making process, right? The final decision-making steps, because essentially we're developing systems for humans. And so it's important to recognize the limitations of machine learning systems here and make sure that we have humans in the loop who can fill in those gaps and ultimately make the final decisions, especially when it relates to the well-being of vulnerable communities on the ground.
So your response actually leads perfectly to my next question. The focus of our podcast this season is exploring the ways AI might be a help in Earth observation and the ways it might be a hindrance. So what are your thoughts on this? Will AI be more of a help or a hindrance in geoscience work?
I mean, based on my experience, AI has been more of a help than a hindrance, really, in terms of making systems more efficient, making them faster, and also more scalable. Processes that used to take months or weeks, where we have humans on the ground doing ground surveys and whatnot, a lot of these processes can be augmented with the help of AI and machine learning. And essentially, development organizations can use this data, which can be very quick to generate given the right input data, like drone images or aerial images. So basically using a combination of AI and Earth observation, we can generate really useful information very quickly and at scale. So I think there's a lot of value to that.
Collaboration is essential in maximizing the impact of science, particularly in fields like geo-AI. The challenges we face are increasingly complex, and finding solutions often exceeds the capacity of any single researcher. Geo-AI problems demand diverse perspectives and a wealth of information, making collaboration a vital component for achieving meaningful progress. Isabelle also highlights the importance of fostering inclusivity in research collaboration, particularly throughout the research process. To make a lasting societal impact, we must engage the community and ensure that everyone involved understands and contributes to the research. So I truly believe that if we can foster the exchange of ideas and keep humans actively involved in how AI is developed and applied, AI will become far more beneficial and impactful. And yes, AI will be more of a help than a hindrance. But one final ingredient to making sure AI is a help: ethics. And that's what we'll be exploring in our final episode this season. In the meantime, learn more about Isabelle Tingzon and her work by visiting her personal webpage on GitHub or by following her on LinkedIn. Be sure to follow us on Spotify and Apple Podcasts, and send some love to our sponsors at IEEE_GRSS on X and Instagram, and IEEE Geoscience and Remote Sensing on Facebook and LinkedIn. This episode was produced by Nicole Bedford from Nicole Bedford Films, with help from me, Stephanie Tumampos. Graphics and design by Mylene Briggs of Kila Media. And a special thanks to Manil Maski and Fabio Pacifici for their support. I'm Stephanie Tumampos, and you've been listening to Down to Earth.